Hey everyone, and welcome. For years, AI in the factory has felt like this buzzword that was always just around the corner. Well, guess what? We've turned the corner. Today, we're going to talk about how AI isn't some far-off concept anymore. It's a real, powerful force that's completely transforming the factory floor as we speak.
So let me start by asking a question. What if a factory wasn't just a building where we make stuff? What if it was more like a living system, one that could actually anticipate its own future? Imagine a place that knew a critical piece of machinery was about to fail, not an hour before, but weeks before. Sounds like sci-fi, right? Well, it's not. It's the exact problem that AI is solving right now. Because, let's be honest, for decades, the main villain in the manufacturing story has been unpredictability. A machine just breaks, no warning. Suddenly, the whole production line grinds to a halt. Everyone's scrambling, and the costs just go through the roof. It's totally reactive, and it is just massively inefficient. Okay, so how are we flipping the script on that old, broken model? Well, it all comes down to a really powerful new set of tools. You can think of it as giving the factory a kind of sixth sense.
First up, and this is the big one, is predictive maintenance. Think of it like this. You're giving a machine the ability to tell you it's about to get sick. It's constantly listening to itself, the vibrations, the heat, the sounds, and AI models analyze all that data to find these tiny little patterns that scream, uh-oh, trouble's coming. This lets you schedule a fix on your own time, not in the middle of a five-alarm fire.
Next up, we've got the digital twin. This is one of my favorite concepts. It's basically a digital stunt double for your actual factory equipment, a perfect virtual copy that's running in real time. So why is that so cool? Well, you can run all sorts of wild simulations, push the machine to its absolute limits, and generate tons of learning data for the AI. And you do it all without ever putting the real, multi-million-dollar piece of equipment at risk. And, of course, you've got the advanced robotics. These are the hands and eyes of the smart factory. We're talking about cobots, which are robots designed to work right alongside people, safely, and autonomous mobile robots, or AMRs, zipping around the floor moving materials. You combine them with AI-powered cameras, and suddenly they can handle these incredibly precise tasks, like inspections, 24/7, without ever getting tired.
So that's the toolkit in theory. But what happens when you actually put these things to work on a real assembly line? What kind of results do you really get? Get a load of this number. It's pretty staggering. A study by Tanger Hossein that looked at smart factories found that by bringing in this AI-driven predictive maintenance, they cut their unplanned downtime by 30 to 40%. That's not just a small tweak. That is a fundamental game changer for efficiency. And this chart really shows you why that matters so much. It tells the whole story in dollars and cents. That huge bar on the left, that's the crazy, unpredictable cost of an emergency shutdown. The tiny little bar on the right, that's the small, planned cost of proactive maintenance guided by AI. The return on investment just smacks you in the face. Okay, but let's get even more specific, because big numbers are one thing, but seeing it in action is another. Research from Panico and Bocaruso gives us this amazing example from aerospace, an industry where, close enough is not an option. Everything has to be perfect. Check out this incredible loop. It's happening in milliseconds. First, the drill senses everything, the force, the temperature, the tiniest vibration. Then, the AI instantly predicts the quality of the hole it's drilling and even figures out how worn down the drill bit is. And here's the magic. It then adapts, changing its own speed or pressure on the fly to make sure the result is absolutely perfect every single time. It's not just doing a task, it's perfecting it in real time. But here's the thing. None of this, not the predictions, not the adaptations, none of it happens by magic. All this incredible AI power runs on one and only one essential ingredient. It needs fuel. And that fuel is data. Lots and lots of data. These AI models are incredibly powerful, but man, are they hungry. To learn, to get smarter, to make those pinpoint accurate predictions, you have to feed them a constant diet of enormous amounts of high-quality data from every single sensor on the factory floor. And this is so crucial. Not all data is created equal. You can have a mountain of data, but if it's junk, you're going to get junk predictions. As research by Harmov and Pisarcik points out, your data has to hit these key criteria. Is it accurate? Is it complete? Or are there big gaps? Is it consistent?
And, maybe most importantly, is it's secure. Getting these 4 things right is a huge job, and it is the absolute foundation for making any of this AI stuff work.
Which, brings us to our final section. Because as amazing and revolutionary as this technology is, the path to the fully smart factory isn't exactly a smooth, straight line. There are some pretty big hurdles to clear.
This slide really lays it all out, doesn't it? On the left, you've got the dream. Zero downtime, perfect quality, just ultimate efficiency. But on the right, you have the cold, hard reality. The challenges that all our sources point to are very real. There's the huge data requirement we just talked about, the high upfront costs to get this stuff installed, and this tricky problem where a model you train for one machine might not work on a seemingly identical one next to it. And then there are the big ones, security and this idea of interpretability, the black box problem. If the AI makes a critical call and you don't know why it made that call, that's a massive problem for safety and for trust. And so, that really leaves us with one final big thought to chew on. We are pouring all of this incredible energy into making our machines smarter, more reliable, more predictable. But what does that mean for the brilliant, creative, and fundamentally unpredictable humans who have to design, manage, and work right alongside them? Figuring that out, that's the next great challenge in building the real factory of the future. Thanks for tuning in.